In this video, I want to talk a little bit about the mean value theorem for integrals. So this theorem states, let f of x be a continuous function on some interval, closed interval ab. Then there exists a number c such that c is between a and b, and f of c is this 1 over b minus a times the integral of from a to b of f of x dx. And so let's kind of break down what this is saying. So let's think about this right-hand side here. What is this? Well, we can think of the integral as a Riemann sum of all the little heights times the little widths. So if we're thinking about a function, we have all little heights. Remember all the little rectangles, it's the way we define our Riemann sum. And we take the limit as this goes to infinity. But what I care about here is that this is a sum, right? And when we divide it by the interval b minus a, we have something that looks like an average. And it turns out that this is an average. So this whole guy here is the average value of f of x on the interval. The average value of f on AB. Should I close right here? And so, excuse me, we claim that there's a number c such that f of c is the average value. So let's take a look at what I'm saying here. So on this graph here, let's say for this function, this is the average value here. Actually, it's probably closer to this. So let's say this is the average value, and we can denote that by f average or f bar. And let's say that this is the average value, the average height of f. Then we can see here that there is a value c between a and b such that f of c is the average value of f. So that's what this kind of theorem is telling us, is that there's a value c such that f of c is this average height. Okay, so let's do some problem solving with this. So our first question is, what is the average value of f of x equals x squared on the interval from -1 to 3? So our theorem states that there is an f of c which is equal to f average, which is the average height of f of x, which is equal to 1 over b minus a times the integral from a to b of f of x dx. Now, remember, a and b come from our interval. So our interval is from a to b from -1 to 3. So our f average is equal to 1 over 3 minus -1 times the integral from -1 to 3 of f of x, which in this case is x squared, dx. Now this is just going to be 1 over 4, the integral from -1 to 3 of x squared dx, and that's just 1/4 times 1/3 x cubed, evaluated from -1 to 3. Evaluating this out, this is 1/4 times 3 cubed over 3 minus -1 over 3. This will become 1/4 times, let's see, this is going to be 9 plus 1/3. Okay, giving these a common denominator to add them. This is going to be 1/4 times 28 over 3. So this is going to be, let's see, 7 over 3. And that is our average height of x squared on the interval -1 to 3. So if we were looking at x squared here, we would have something like this, where this is our average value. That's 7/3. Yeah. So next we want to find the value of c that satisfies the conclusion of MVT. So remember, our MVT claims that there's a c such that f of c is this. So we want f of c equals 7 over 3. We also know that f of x equals x squared, so f of c equals c squared. So there's some c squared such that it's 7/3. I can take the square root of both sides and get that c is equal to plus or minus 7 over 3, the square root of that. And then remember that my interval is -1 to 3, and only positive 7/3 is in that interval. So we pick the positive value. So it's the square root of 7 over 3. And that would be the c value that satisfies the theorem. Okay, next, given that the average value of f of x on the interval 0, 3 is 27, what is this integral from 0 to 3? So remember, let's just rewrite our theorem. What it states, f of c, which is f average, is equal to the integral of, 1 over b minus a times the integral from a to b of f of x dx. So plugging in what we have here, my interval a, b, and then this right here, this 27 is f average. We have that, plugging this in here, 27 equals 1 over 3 minus 0 times the integral from 0 to 3 of f of x dx. Now, this means that 27 is equal to 1 over 3 times the integral from 0 to 3 of f of x dx. Now, I can multiply both sides by 3 and get that the integral from 0 to 3 of f of x dx is equal to 3 times 27, which I believe is going to be 81. And that would be my final answer. And that kind of sums up what I have to say about the mean value theorem for integrals.